Thanks for the lovely introduction. So yes, today I'm going to be talking to you about metaclasses. First of all, why metaclasses? Why would you care about metaclasses? Well, the short version is that there's things you can't do with classes, and metaclasses lets you do these things. And so I'll spend the rest of the talk trying to explain what those things are and how exactly you would do them. The reason why I started playing around with metaclasses was I was trying to use nose to run some test suites, and I ran into this problem where nose will print out the docstring of your methods as it's running them. And these docstrings aren't necessarily particularly informative. So if you have some, class A, and it has a function called myfunc, it has some docstring for the function, and then another class that inherits from A, and then you look at the docstring for both of those functions, they're the same docstring. So you don't actually know if you're getting that function through class A or through class B. This is normally not a problem, but in these specific cases, like when you're trying to use nose for this, it makes it very hard to debug and see which of your test cases are actually passing and which are failing. So I set out to try to find a solution to this. So the simple solution, which you might think of, is just to include the information manually in the docstrings. That's probably the best solution for simple cases. You just change A and B, there you go, you're done. But if you have lots of methods or lots of subclasses, this can get pretty arduous. There should be a better way to do this a little bit more programmatically. Here's maybe a better solution to try to fix this. So what you could do is say, aha, I'll just edit the docstring in the init of the parent class, and then that'll fix everything. So you go for each of your functions, in this case it's just myfunc, but if you had more, you could do more. Look up the class name and edit the docstring so that it's prefixed with class name : docstring. Unfortunately, this doesn't actually work because the docstrings for class methods are not writable. You can't change them after the class has been created. So it doesn't work to just edit them in init. You need to do something a little bit more fancy. I'll note that in general, docstrings are writable for functions. If you just have any random function, that is fine. But it's, in particular, methods, the docstrings aren't writable. So this is specific problem to classes in particular. So is there a way that we can perhaps maybe change the docstring before the function becomes a method? And the answer is yes. But to take a step back for a moment and just sort of give a brief refresher on the basics of classes. So what's a class? A class is just a special type of object that creates other objects, and those other objects are called instances. Remember that everything in Python is an object. If you haven't heard that before, now you have. Everything in Python is an object. That's the most important thing to remember from this talk, is everything in Python is an object. So all objects act basically the same. To give sort of a real-world example that I like to use is that a class is sort of like a particular government form, a tax form, like the 1040. And then an instance would be your particular version of that tax form with all of your information written out on it. We can ask Python what flavor of object a particular instance is, what class it is. We use that using this type function. And so here it'll tell us that A_inst is of type A, which is what we would expect because we created it from A. But again, everything in Python is an object, so therefore classes should have types too. And in fact, if we look at what the class or the type of A is, we see that it is of type. This is kind of confusing because a lot of people use the term type in sort of a general sense, but in Python there's also the specific term of type. And to make it even more confusing, there's sort of 3 different ways that type can be used. So first of all, type will just denote the flavor of object that it is. That is to say, the type of what a class is. You can also use type as a function to tell you what type of particular instances that you have, which is probably how you've seen it used before. And finally, you can use type to create new classes. And that's the interesting part that I'm going to be getting more into now. So how do you create a class on the fly? You use type. This is how you've probably seen classes instantiated before. Probably you haven't seen them instantiated in a different way, but you can using type. It takes 3 parameters. The first one is just the name of the class. The second is a list of base classes or parent classes, so that's equivalent to what you would put here up in the parentheses. And the final one is a dictionary of the attributes that the class will take. And so in this particular case, I just have the attribute for my func, but if you wanted to have other variables or methods, etc., you'd put them in that dictionary. So you just pass those 3 arguments, and voila, you have a class. You don't need to use the special class syntax to do it. OK, so now that we know how to create a class on the fly, maybe we can try this again, see if we can get our doc strings rewritten. I created a function here called makeClass, which has the same signature as the type function. But before it actually calls type, it goes through each of the methods that are passed in and rewrites them to, again, be prefixed with the class name. We can call this make class A and make class B, but unfortunately, this isn't exactly what we wanted. What we see is that when we print the doc string of my func for A, it is in fact prefixed with the A colon, which is what we wanted, but then B is B colon, A colon. So how did that happen? The answer is that both of those classes A and B were using the same function in memory. So when you first rewrote the one for A, it prefixed it with A colon, and then you rewrote the same doc string a second time and got B colon, A colon. And so if you actually use is, which does equality in memory, it'll show you that those 2 functions are exactly the same. So can we get around this by perhaps making them not be the same function? So again, everything in Python is an object. So we can also create functions on the fly. Functions also have a type, which is the function type. So here's a function that takes a function as an argument, and then copies the function and returns the copy of the function. You don't need to worry too much about the details of how this works. This is really getting into the internals of Python. Actually, the first argument that it takes is the compiled bytecode for the function. Yeah, don't worry too much about the specifics there. Just know that you can actually duplicate functions. So we have this. All right, so we'll take my func and we'll copy it to create my new func, and then change the doc string for my new func, and we print out the doc strings, and it is in fact modified. The second one is, the first one isn't. So this seems to be the behavior that we want. Take 3 now. We'll try it again. We're going to modify our makeClass function to, before modifying the doc string, also copy the function that it's been given, and then create the class using these new copied functions, and hopefully this should work. And in fact, it does. So here we're making class A, making class B. They both take my func, which are the same object. But because this makeClass function now copies the functions, we get different doc strings for the 2 different methods. All right. So you might be wondering why I haven't mentioned metaclasses in a while, given that this is a talk on metaclasses. But actually, the whole time I've been talking about metaclasses. So a metaclass is just any callable, which means a function or a class that has a call method. Well, technically, metaclass uses new, but anyways. It's any callable that takes the parameters for the class's name, the class's bases, and the class's attributes. And so type, that we were using to create classes before, is just basically the default metaclass. That's what happens under the scenes. You never see it, so you never have to worry about it. And the function that we've been developing, this makeClass function, is technically a metaclass too. I know it's confusing because that's a function, not a class. But and so what makes this a metaclass? Again, it takes these 3 arguments for the name, bases, and attributes. It then modifies those attributes. Specifically in this particular instance by creating copies of the functions and then modifying their doc strings. It then creates a new class using these modified attributes and returns the new class. That's all a metaclass does, is it intervenes on class creation time, makes some adjustments, and then so the class that's returned is slightly different than it otherwise would be. So now Python has some special syntax that we can use, so we don't actually have to. So if I go back to, so we don't have to necessarily make classes like this. We can still use our nice like class name, parentheses, colon syntax that we're used to. We don't have to do it like that. That's a special syntax to do that. Oops. But Python creates classes a slightly more complex way than the way that we've been doing it. In addition to the myfunc or whatever attributes you define, it'll pass in special ones like underscore underscore init, underscore underscore, and various variables too. So I'm just adding to the for loop here to skip special methods and non-functions. So we're not going to touch those. And then here's the syntactic sugar, which is just you add this attribute called underscore underscore metaclass underscore underscore. You set it to whatever your metaclass is that you want it to be. So in this case, our make class function. And it just, that's when the class is created. That's basically like when you import the module or you run that Python file, the class is created, and the metaclass goes through, modifies the class. And so when you actually create an instance of the class, and check the function, you see that the docstring is modified. Note that this is slightly different in Python 3. The syntax is a little bit different. This is for Python 2.7. But I'll be posting these slides online. You can look up what the syntax is for Python 3. OK, so just to take a step back, what exactly was it that we did? I.e. getting meta about metaclasses. Again, metaclasses intervene on the class creation. Again, that's class, not instance. So it's the thing that creates instances. We're changing that thing. And because we're able to intervene on class creation, we can make some changes. And in this particular case, we copied the functions, changed their doc strings, and then we finally created the class using those modifications. A quick side note, if you were to run the code that I actually gave you and try to do the subclassing thing, it doesn't actually still quite work, but the reason is kind of a stupid reason that I didn't want to get into the details for. Basically, you need to, the myfunc is not an attribute that you would pass into B because it's already an attribute of A, which is the superclass. So in order to make this work, you'd have to go through manually all of the attributes of all of the parent classes. I have all of the code on the blog post that inspired this talk, so you can go look at it if you really want to. But I think the cool part at all was that you're able to rewrite the doc strings for the methods that are part of the class originally. So that's a fairly simple example of what you might use a metaclass for. You'll find other instances of people using metaclasses. One really commonly cited example is that Django uses metaclasses to sort of simplify the interface. So if you create for example, a person class, which is, so forgive me if I get this wrong, I haven't used Django in a long time, but if you create a person, which is supposed to be a model for like an interface to your database or to represent various, like a character field, integer field on your website, if you create that class and then you actually create an instance of the class, you'll find that the attributes aren't these like fancy character field or integer field types. They'll just be like integers or strings. So it makes it a little bit easier to work with these classes as a user, and all of the fancy stuff underneath is handled by this metaclass rewriting these attributes. And the source from this is this really great Stack Overflow answer, which I highly encourage you to go look if you want to find out more about this. So a word of caution, which is that metaclasses can be really hard. They can make your code really hard to understand. Like I get confused going back and looking at my code that uses metaclasses, and I wrote the code. So if someone else is going to go read your code, like really there are instances when metaclasses are very useful, but you really should only use metaclasses if you absolutely, really need to use them. And there's this great quote that's attributed to Tim Peters, who's he wrote like the Zen of Python. Metaclasses are deeper magic than 99% of users should ever worry about. If you wonder whether you need them, you don't. The people who actually need them know with certainty that they need them, and they don't need an explanation about why. I think that this is true, though, unless you're like me and you just like kind of playing around with the obscure parts of Python and coming up with a reason to try to play around with this. I think like the takeaway from this is I totally encourage people to play around with their own code, find out about cool things like this. But if you're actually working on code that's going to be used by people and read by people, don't use metaclasses unless you are certain that's the thing you need to be using. So that's it. Like I said, I'm going to be posting these slides. So if you want to go back and look at the examples and stuff that I gave, you can just go to my website, which is jesshamrick.com. And also, this presentation was created with IPython Notebook, which is awesome, and just automatically renders all of the Python code, etc. It's great for slides and everything else. But thanks.
OK, that's a lot to think about. What questions do we have for Jess?
Just out of curiosity, have you looked at class decorators?
Yes.
So metaclasses make my eyes cross. Class decorators seem pretty obvious, but it seems like there's some limitations. Are there things you can do with metaclasses you can't do with class decorators? Yes.
So in this particular case, you could use class decorators to do the docstring rewriting, but then you need to use a decorator for every single method that you have, which is kind of annoying. Sure. So yeah, this is a case in which if you don't actually want to do it for every single method, then you need to use something like a metaclass. But in a lot of cases, absolutely, decorators can do a lot of stuff that, if you think you need a metaclass, you might be able to do it with something like decorators. So.
If you have a class named C and a method called F, and you want to change the doc string for it, you could say c.f.imfunc.doc equals the new value. And so that way you could change the doc string in place.
.imfunc?
Yeah, .imfunc.
Interesting. OK, didn't know that. Thanks.
We have one right over here.
So would you consider Django's usage of metaclasses to be valid, or a good use case, or just one that's confusing?
I think in this particular case, it is probably a good use of metaclasses, because the way that you create Django classes is, at least from my experience with Django, it's a little bit you use it not quite like you'd use Python normally anyways, and so I think it's probably fine, but I also don't have enough experience with Django to give a confident answer to your question. But I think it's probably good.
Adam? I actually have a response to that question. I think that Django does a good job with metaclasses, and it's because if you're just using the Django API normally, you don't know it uses metaclasses. Mm-hmm. So the advice that you put up there is totally valid earlier. Metaclasses are great for doing complicated things inside of frameworks, and inside of the framework. As soon as it crosses that end user API, you're probably doing it wrong. So you don't know they happen in Django unless you really go into Django internals. So awesome use, great API.
OK, thank you so much for that great talk, Jess.
Thanks.